This is lesson 7-3, proving triangles similar. We know with similar triangles that the angles are congruent and the sides are in proportion. So there are three different ways I can actually prove that two triangles are similar. To show that two triangles are similar, you only need to know the relationships between only two or three pairs of corresponding parts. So the first way is called angle-angle similarity. So I use two A's for angle-angle similarity. And it says that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if I have two angles of one triangle, I have triangle SRT right here, and angle S is congruent to angle M, and angle R is congruent to angle L. So if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Actually, remember, all three angles will be congruent. Angle T will have to be congruent to angle P because of that third angle theorem. But all we need to have is 2 because the third one automatically is congruent. So if angle S is congruent to angle M, that's one angle. And if angle R is congruent to angle L, then the triangles are similar. So I say triangle SRT is similar to triangle MLP. And the order of the letters shows which angles are actually congruent. The S is congruent to the M, the R is congruent to the L, and the T is congruent to the P. And remember, this is my little sign for similar. So let's look at the first example. I want to see if the two triangles are similar or not. Okay, so I have triangle RWS over here and triangle VBS over here. All they're showing me is one angle. Angle R is congruent to angle V. They're both 45 degrees, and they're not telling me anything else. But these triangles are similar, so try and figure out if you can, what other angle do I know, and mark it on your picture, and then you can answer the question. Okay, another way to prove triangles similar is side angle side similarity. So SAS similarity. This is different than when I have side angle side congruence. So side angle side similarity. If one angle of one triangle is congruent to an angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. Okay, so I'll say that again. If you have an angle of one triangle congruent to an angle of a second triangle, so the angle is congruent, and the sides that include the two angles are proportional. So the angle in the middle is congruent and the sides on either side, they're not congruent, they're just proportional, then that's enough to say that my triangles are similar. So if I look at my triangle ABC right here and triangle QRS, see how angle A is congruent to angle Q? So I already have the angles congruent. I need the sides being proportional. So AB, which is this side right here I have marked in red, is over QR equals AC over QS. So basically the left side over the left side equals the right side over the right side. And I have the angle between those two sides. So then I know that they're similar. So triangle ABC is similar to triangle QRS. The angles are congruent and the sides that include the angles are proportionate. So that's side angle side similarity. The last way is just side-side-side similarity. So if the corresponding sides of two triangles are proportional, then the triangles are similar. If the corresponding sides of two triangles are proportional, so I don't know anything about the angles, all I know is all three sides are proportional, then the triangles are similar. So if AB over QR equals AC over QS and BC over RS, then my triangles are similar. You have to have all the sides having that same ratio so that they are proportional. And then the angles automatically will be congruent because once the sides are in proportion, they're similar, and then we know that those angles are going to be congruent. Sometimes we can use this if I'm trying to indirectly measure something. So indirect measurement says, if the length cannot be measured with a ruler or other measuring device, then we can find the length by indirect measure, forming similar triangles. Like if I wanted to measure the height of this clock, I can't really take a tape measure and climb up and measure the height. But what I can do is sort of set up a similar triangle. So I know the person knows the height, and how far away they are from this point, this mirror. They're 4 feet away. A clock is 10 feet away, so they're both right angles, so there's your angle. These angles are both congruent, so therefore my triangles are similar and I can set up a proportion. Okay, so what I did is I set up a proportion. I have this 5 feet 6 inches is 5.5 over 4, so I have the height over the base equals the height over the base. So I have the height of the man over the base right here of the triangle, and the height of the clock over the base of this bit larger triangle. And then all I need to do is to cross multiply to solve that, so you can do that. So cross multiply and solve for x, and then you know the height of the clock. And that's it for today.